Hello friends, welcome to my channel Maths Realization. Today we are going to learn about real numbers. So let's start our class.
Okay, let's start with the real numbers. So to know the real numbers, first we have to know its elements or the components inside the real numbers, like natural number, whole number, okay, rational, irrational, like that. You have to know these numbers so that you can clearly understand or you can clearly make an idea about the real numbers. So let's start with the natural numbers. So natural number, okay, is numbers starting from 1 and goes to positive infinity are called natural numbers. Means the numbers we are using in journal are from 1, 2, 3, 4 and so on, like millions, trillions, up to where you will count. All the numbers are called the natural number that is starting from 1. Okay, these are the natural numbers. After that we will see the whole numbers. Okay, whole numbers, yeah. So the numbers starting from 0 to positive infinity are called the whole numbers. So you can say like this: the numbers starting from 0 and goes to positive infinity. This is positive infinity starting from 0 are called the whole numbers. Okay, after that, after whole numbers we will see the integers. So the integers starting from negative infinity to positive infinity are called the integers. Yes. So in natural number started from 1, whole number started from 0, and integers from minus infinity to plus infinity. That is minus infinity and then increases and goes to increases up to 0 and then 1, 2, 3, 4 to positive infinity. These all numbers are called the integers. Okay, it means natural number is a subset of whole number is a subset of integers. Okay, you can say like that. And we can divide integers in 3 parts, like negative integers. Yes, all the negative numbers are called the negative integers, minus 1, minus 2, minus 3 up to minus infinity. Similarly, we can say positive integers, like starting from plus 1 to plus infinity are called the positive integers. And 0, yeah, because 0 is neither positive nor negative, so we will write it separate, but all of these numbers are the integers, isn't it? And then we will see rational numbers. So rational numbers is also inside the real numbers. So rational number means a number which can be expressed in p by q form. Okay, this p by q, here q is not equal to 0. Q does not equal to 0 means if you write here 0, then something means any number like positive, negative, any number upon 0 is undefined. Okay, so it is not defined in mathematics. So q must not be 0. Q must be some numbers. It is not 0. Okay, at that time, if any number that is expressed in p by q form, we call it rational number. Yes, rational number examples are like this: 0, 1, 2 means these are natural number, whole number, integers are there, and yeah, fraction. Main thing is fraction. So we can express all these 1, 2, minus 7, minus 13 into fraction. So like in this form, p by q form. So 3 by 4, 1 by 3, these are all the rational numbers. So fraction can be changed into decimal. So decimals are also the rational numbers. So 3 by 4 means some decimal will occur and you can say it is a rational number. But not all the decimals are rational numbers. So let's see what type of decimals are rational numbers. So you have to know the about the decimal numbers that are rational. So terminating decimal, all the terminating decimal are rational numbers. So like terminating decimal means the fraction which can be expressed in this form, like 0.75. 3 by 4 is equal to 0.75 means after 0.75 there is no digits or no numbers after 5. That is, 5 is the end point, or you can say any decimal which have end point is called terminating decimal. Okay, so that is, it means the decimal terminates or ends after 0.75, which means there is no number after 0.75. Another example is like this, 2 by 5, which is 0.4. So there are many terminating decimals which are, you can say, they are rational numbers. All the terminating decimals are rational numbers, but all decimals are not rational numbers. I will explain here. So now the non-terminating decimal. So in non-terminating decimal, non-terminating means it has no end point. No end point, like the decimal goes to, after decimal the digits move up to infinite, like 3333. This will move on. 1 by 3 fraction, it changes into decimal, it moves up to infinite, these digits. Similarly, another example, 4 by 7. So here is these digits like move on up to infinite, there is no end point. Similarly, pi, yeah, pi is also a non-terminating decimal. This digits after decimal, this is the decimal, after decimal the values move up to infinite, there is no end point. Okay, so again, non-terminating decimal is divided into two parts. You can divide it into two parts. Like first part is non-terminating recurring decimal. Okay, non-terminating recurring decimal. Non-terminating recurring means, so like this, recurring means repeating. Okay, recurring means repeating. So 1 by 3, when you change this fraction into decimal, it moves on like 0.33333 and moves up to infinite. Always there will be 3. So we can write this into this form, like 0.3 bar. This bar represents, like you are seeing this small line on the top of this 3. So that bar represents this number is repeating, 3 is repeating, like 0.3. This the bar on the top of this number represents if this number is, or this digit is repeating. So here also, or you can write it in the form 0.3 dot. This dot also represents the same thing. Either you can write bar or you can write dot here, so that it represents this 3 is repeating. So let's see another example like this, 4 by 7. So in this fraction you can see like this, 571428, again 571428, again 571428. So this will repeat in a group of numbers like 571428. Again similarly from 571428 will be repeated, again same number will be repeated. So we can write it like this. We can write 571428, or we can put a bar on this number, means this group of number, this group of digits is repeating, or means or recurring. So this is non-terminating, but some of the digits or some of the numbers after decimal are repeating in the same pattern. They are repeating. Or you can also write like this, dot here and dot here, means these are the repeating digits or numbers starting from 5 and up to 8, means after this 8 again 571428, 571428 will be repeated up to infinite. Okay, so here we can say it means the number after the decimal does not terminate but repeat after certain interval. So these 3 represents repeats after every interval, but here the numbers repeated after some interval. Okay, that is not, these are the form of non-terminating recurring decimals. And another type is of non-terminating decimal. There is another type where we call it non-terminating and non-recurring decimal. So non-recurring means here in recurring the digits are or the numbers after decimal are repeating, but in non-recurring decimals the numbers or digit after decimal does not what repeating or does not repeat it. Recurring or non-recurring means they are not repeated. Here the numbers are not repeated and but they goes up to infinite. So this is non-recurring decimal. So we for non-recurring decimal we cannot change non-recurring decimal in fraction form, in p by q form. So this type of decimals are not rational number. Here non-terminating recurring decimal like this, non-terminating but recurring decimal we can write it in fraction form, p by q form, this form. So they are rational numbers, but this type of decimals which are non-terminating and non-recurring, this type of decimals are not a rational number. They are not rational number. So there is a this is not repeating and its value is up to infinite. For pi, scientists have found up to around 10 millions, the 10 million digits after this decimal by using the supercomputer. So you can search in the internet also. And so by using supercomputers, scientists have found up to the digits up to around 10 million, more than 10 million I think. And they are searching up to that accuracy. They have found the digits after decimals. That's an interesting fact about the pi. This is another. This is the definition. It means the number after the decimal does not terminate and does not repeat. This is the definition of non-terminating, non-recurring decimal. And now we are talking about the irrational number. So irrational number which cannot be expressed in p by q form. I already told here that this pi cannot be expressed in p by q form. But in some books or somewhere you will see that pi is also represented as 22 by 7. But
22 by 7 and pi are not exactly equal. They are equal up to 2 values only. After the decimal they are equal up to 2 values, like pi has value 3.14 and something later they are. After that there is difference in numbers between pi and 22 by 7. So they are not exactly equal.
For our simplicity, we are just using 3.14 as 22 by 7 or pi. So sometimes we will use 22 by 7, but it is not the exact value of pi. 22 by 7 is not the exact value of pi. 22 by 7 means it is a it is what? It is a rational number, but pi is not a rational number. So don't be confused with 22 by 7 and pi.
So here pi equal to 3.14159265 and so on. So pi is non-terminating and non-recurring decimal, but 22 by 7 equal to 3.142857, again 142857, which means 22 by 7 equal to 3.142857 bar. Okay, so 142857 is the recurring digits. So 22 by 7 is non-terminating but recurring decimal. Okay,
so irrational numbers, I am talking about the irrational numbers which cannot be expressed in p by q form are called irrational numbers. So irrational numbers I have already explained. So the numbers like root 2, root 3, the roots of the prime numbers, okay, or square root of prime numbers, or like this cubic root of 6, fifth root of 9. In this way these are the irrational numbers which these numbers cannot be expressed exactly in p by q form. So these are irrational numbers, and pi is also an irrational number. We cannot express pi in p by q form. So in this like root 2 1.4142, we cannot change the decimal in p by q form, so it is a irrational number. Like root 3 is there and 5 root 9 is there, pi is there. Yeah, these are the values of these numbers, but they are not, we cannot express them in p by q form, so they are irrational numbers. Now the main thing is real number. Okay, so to explain real numbers you have to know all these 5, all these decimal, irrational, rational, natural, whole number, all these numbers. And yeah, all numbers, all natural numbers, whole numbers, integers, rational and irrational number are called real numbers. So all the numbers we have discussed up to now are all the real numbers. Okay, so next we will express this real number in some diagram form. So let's see. This is the diagrammatic representation of real number. So this is the most important part, so that you can see in figure how the real number can be expressed in diagram or represented in diagram. So real numbers. Okay, I have close it inside a rectangle. So first I will start with natural number. Okay, so you know the natural numbers, 1 2 3 plus, from plus 1 to plus infinite are the natural numbers. And after that, after natural numbers, you will see the whole number. So whole number have, yeah, you can see this red ellipse. These are not exactly circle, these are ellipse. Okay, so you will see natural number is inside the yellow ellipse and whole numbers is inside the red ellipse. So I have written here 0 only, because this natural number is a subset of whole number, means 0 1 2 3 up to infinite. This red ellipse represents the whole number, so natural numbers is also inside the whole number. So I don't have to write again and again 1 2 3 4 here to infinite. So I have just written here 0, whole number started from 0, and again this is also, natural numbers are also inside the whole number. Then after that there is integers. So in integers, this dark green ellipse represents the integers. So integers are like minus, negative integers, minus 1 2 3 up to minus infinity, and there is 0 inside the integers also, and there are natural numbers 1 2 3 for positive numbers also inside the integers. So I have written here negative integers only. So 0 is also inside the integers, and these positive numbers are also inside the integers. So I don't have to again write it here. Okay, so in this way I am drawing this diagram. So yeah, okay, so this color represents the, or is this I think it's pink color. Yeah, it represents the rational number. So there are fraction. Yeah, we have not seen here decimal number up to integers, like natural number, whole number and integer does not have decimals. So these 3 by 4 can be changed into decimal or fraction. This is a fraction and we can change it into decimal. So rational number includes positive and negative decimals. Okay, so we have discussed already about the rational numbers. So rational number also include natural, whole and integers. So this is all integers, whole numbers and natural numbers are the subset of rational numbers. After that, rational number, I have drawn a circle here outside these. Why? I have to write for, I have written here irrational numbers. So irrational numbers are did not match with these numbers. Irrational numbers are different from these natural, whole, integer and rational numbers. So I have written it separately. Okay, so they are pi, root 2, root 5, all the numbers that cannot be taken out from the square root, any root, not square root only, cubic root or fourth root, like that. So those are which cannot be expressed in p by q form, those are irrational numbers, like this, etc. Okay, so this is the complete diagrammatic representation of real numbers. So I hope you understand and you like my video. So if you have not subscribed to now, please subscribe my channel and share with your friends. Thank you. Bye bye.